Hello everyone, welcome to my channel Cafe Mathematics. Today we will talk about the derivation of hyperbolic functions. As the name suggests, hyperbolic functions may relate with hyperbola in the same way as trigonometric functions relate with circle. So let's see how trigonometric functions relate with circle first. Then we will use the same approach for hyperbola. So let's suppose we have a unit circle. The coordinates of the circle can be represented by parameter theta, and thus x coordinate is cos theta and y coordinate is sin theta. Note that currently parameter theta is external to circle, or in other words does not hold any property of the circle. So let's do some trick. Let's suppose the parameter is now u, and parametric equations will become x is equal to cos u and y is equal to sin u. Let's compute the area of a sector of the circle. As circle is of radius 1, thus by area of sector formula, area of sector becomes theta by 2. Now let us take u is equal to 2 times area, and 2 times area is equal to theta, thus u is equal to theta. So substituting u in parametric equations will give us the original parametric equations. X is equal to cos theta and y is equal to sin theta. But note the difference that theta is intrinsic parameter now. In other words, theta is actually representing the area of the circle. In other words, the parametric equations of the circle now depend on some property that is intrinsic to circle, its area. So now we will do the same with hyperbola. So let's suppose we have a parameter u, and parametric equations of unit hyperbola be x is equal to cos hyperbolic u and y is equal to sin hyperbolic u. Now we will set the same as before, u is equal to 2 times a. So now suppose a point a comma b is on hyperbola and a line from origin to this point. We have to find the shaded area, as area is between line and hyperbola. So compute the equation of the line. Line passes through the origin and through point a comma b, thus it has slope b over a, and thus its equation will be y is equal to b over a into x. So now let's integrate by using x as a function of y. So the area integral gets this shape. Evaluate this area, it gets equal to this, and as point a comma b lies on hyperbola, so it must satisfy its equation. So from there we get a is equal to square root of 1 plus b square. Substituting this in area expression, we get this final expression for the area. So now what is 2 times area? That is natural log of b plus square root b square plus 1, which is equal to u. As we said early, u is equal to 2a. So now we have to solve for b. Take exponential on both sides, so we get this expression taking square and cancelling terms. Finally we get b is equal to e power u minus e power minus u divided by 2. So we have calculated y coordinate, because b is y coordinate and y is equal to sin hyperbolic u. So this means b is equal to sin hyperbolic u for some value of u, and thus sin hyperbolic u is equal to e power u minus e power minus u divided by 2. And now we can calculate for cos hyperbolic u independently using same procedure for a, or using the identity cos hyperbolic square minus sin hyperbolic square, u is equal to 1.